Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam LTAM. It's a written answer problem. For a fully discrete 3-year term insurance of $100,000 on Anne, age 40, you are given Anne's future mortality follows a double decrement model, where decrement 1 is death from disease 1, decrement 2 is death from any cause except disease 1. And the force of mortality due to disease 1 is of the form A plus B C 40 plus T for age 40 plus T for all t greater than or equal to 0, where A is 0.0001, B is 1.075 times 10 to the negative 5, and C is 1.12. The force of mortality due to other causes is 3 times the force of mortality due to cause 1. Interest rate is 5%, which is the rate in the table used on the exam, standard ultimate life table. Question A. Show that P40 tau is equal to 0.995 to the nearest 0.001. You should calculate the value to the nearest 0.0001. You are also given that 2p40 tau is 0.99027 and 3p40 tau is 0.98462. Part B. Show that the expected present value at issue of Anne's death benefits is 1400 to the nearest 100. You should calculate the value to the nearest 1. Part 2 of B. Show that the net annual premium for Anne's insurance is 490 to the nearest 10. You should calculate the premium to the nearest 0.1. Anne purchases a policy rider that pays an additional $50,000 at the end of the year of death if death is due to disease 1. Part C. Part 1. Write down an integral expression for TQ41 in terms of the dependent survival probabilities, SP40 tau, and the force of mortality from disease 1, mu 40 plus S1. 2. Using your expression from part C1, prove that TQ40 upper 1 is equal to 1/4 TQ40 tau. Part 3, show that the net premium for the disease 1 rider is 60 to the nearest 10. You should calculate the premium to the nearest 0.1. Part D, calculate the net premium reserve at time 1 for the policy, including the disease 1 rider. Just note that when we talk about this disease 1 rider, this refers to the statement before Part C, which says Anne purchases a policy rider that pays an additional $50,000 at the end of the year of death if death is due to disease 1. And here's the solution for Part A. We have mu 40 plus t, 1 is A plus B C 40 to the power 40 plus t, and mu 2 40 plus t, 2 mu 2 is 3 times mu 1, so that mu tau is the sum of the two is just 4 times what mu 1 is, and that's 0.0004 plus 0.00043 times 1.12 to the power of 40 plus t. From the SULT table, we know that when the force is of the form a plus b times c to the x, tpx is of the form e to the minus at minus b over natural logarithm of c, c to the x, times c to the t minus 1. Therefore, p 40 tau is equal to e to the minus 0.0004 minus 0.000043 over natural logarithm of 1.12 times 1.12 to the 40th times 1.12 to the first, because t is 1 in this case, minus 1, and that's approximately 0.995374. And of course, you could do this calculation by taking integrals and doing a lot of hard work, but this information about this form of force of mortality is in the table. Just look it up. And therefore, this is given to you so that you use it. You don't have to do this calculation. Remember that the general rule is that if you're calculating an integral on exam LTAM, it's very likely that you're doing it wrong. Most of the time, they want you to either know the answer, know the situation, or look it up in the table. Always remember. So remember that this information is in the table. Part B, 1. The expected present value at issue of Anne's death benefits is 100,000 times the sum from k equals 0 to 2 of 1.05 to the minus k plus 1, because it's at the end of the year that is paid. Probability of survival to the beginning of the year times probability of dying from any cause at the end of the year. And then we can write this probability here as the difference between probability of survival of k years from any cause minus probability of survival k plus 1 years, and we actually have the form, the information about these values for k equals 0, k equal 1, k equal 2. Well, we calculated one of them and the other two are given, so we just plug them in and we get approximately 1301.59. Part B, part 2, the expected present value of the premiums is P times 1 plus the probability of survival of 1 year over 1.05 plus probability of survival over 2 years over 1.05 squared. That's approximately 2.84617.9p, and therefore P is approximately, because these two are equal, because we're using the equivalence principle, so 1301.59 is equal to this 2.84617.9p. Therefore P is approximately this is a typo, so let me try to fix it quickly. 1301.59 over 2.84617.9, and it's approximately 488.93. For part C1, we have TQ41 is equal to the integral from 0 to t SP40 tau, the probability of survival until time s, times probability of being whacked by decrement 1 at that moment s, and it's over all possible times from 0 to t. So times mu 40 plus s1 ds. Part C2 tells us that TQ40 tau is the integral from 0 to t. Well, actually, it doesn't tell us that. We figured it out. Anyway, this is integral from 0 to t SP40 tau times mu 40 plus s tau ds. And of course, the mu tau is the sum of the two forces, which is 4 times force due to decrement 1. And therefore, this is equal to 4 times TQ41. And therefore, TQ41 is 1/4 of TQ40 tau. Part C, part 3, the expected present value of the disease 1 rider, of the benefit for the disease 1 rider, I should have said, for the disease 1 rider is the sum from k equal to 2 of 50,000 divided by 1.05 to the k plus 1, which is just the present value of the benefit, times the probability of dying to collect that benefit for k equal 0, 1, and 2. It's the probability of dying within a year but deferred by k years. And then this is equal to the expression you see here. This is just calculated by taking 1 minus the probability of survival for the first one, but then it's adjusted for surviving to the beginning of the year and not surviving to the end of the year. That's why the difference of those two values of survival function for the remaining two. And by the way, 1 is of course the probability of survival to the beginning of year 1. And that's approximately 173.95. The expected present value of the unit annuity paid the way the premium is paid equals, as we know from previous calculation, 2.846179. And therefore the premium for this rider is 173.95 over 2.846179. That's approximately 61.12. Finally, part D. What is the reserve at time 1? Well, it's going to work this way, that we can start with the reserve of 0 at the beginning and do the reserve formula, a recursive reserve formula. So the reserve at time 0 plus the premium for the basic coverage plus the premium for the rider accumulated with interest minus the benefit paid for the basic policy minus the benefit paid for the rider. All of this will give us the reserve at the end of the year. But the reserve is kept only for those who survived. So the reserve at time 1 has to be that expression divided by the probability of survival of the first year. All of these numbers are known to us. And so we just plug them in and do the calculation, and we get 57.39. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.